All right, let's get started. All right, so let me get the lights adjusted a little bit. Okay, so tonight what we are going to do is a fundamental review of math on the FE exam. So this is appropriate for you civil engineers, you mechanical engineers, you engineers who decided that this is what you wanted to do with your careers. This is, by and large, the largest section on the exam. And not just because you are going to be asked specific math questions, but I got news for you. If you thought you were going to get through the FE without having to do any math about that, not going to work out too well for you. But in all seriousness, the actual direct math questions you're going to get asked on the exam are fairly basic, and it's just meant to assess your overall knowledge of the topic. And that's the case with just about every section on the exam. The way I like to describe it is you don't really get asked very many difficult questions on the FE exam. You just get asked a lot of them, okay? So don't get too worked up over a given task or a given topic. It's not so bad. All right. Tonight, what I've got for you are 20 questions. I will admit I have done a fair amount of surgery with these problems. They are designed to cover as much math as possible in as few questions as possible, okay? And when it's all said and done, we're going to start at algebra and end up at DiffyQ and everywhere in between, okay? So I'm also going to try and emphasize the use of the manual and just your fundamental understanding of some things. Now, who didn't bring a calculator? Who brought an NCEES approved calculator? Good, there you go. All right, NCEES does not care what calculator you use as long as it's on the list, okay? Now, for our Engineering 111 computations course, we tend to hamper on the Casio FX115, so, you know, that's the one I have here on this slide, but I have that there solely because that's the one we use here at Marshall. But, I mean, I got a whole host of other calculators over here. I've got Casios, I've got TIs, I've even got RP and HP calculators. As long as it's on the list, you can use anything. My advice to you is whatever calculator you're going to use, know that calculator. For instance, the Casio will do numerical integration of definite integrals. It'll do it for you. So know it. It will do equation solving. It will do simultaneous equation solving. It will do statistics for you. Make sure that you understand those functions. Yes, sir?
Can we bring multiple calculators to the FE exam?
That's a good question. Can you bring multiple calculators to the FE exam? And unless the rules of change, the answer is yes. When I took my FE, I actually brought two calculators. I brought an HP RPN calculator, and I brought a TI, okay? And they each served a particular function. If you have a long, convoluted calculation that needs to be performed, using RPN actually is a little more efficient because it's quick. You can, let's put it like this. The same calculation that would take 30 different button presses here might take 16 button presses here, just because of the notation. But I liked my TI because I thought it was, I understood the statistics functions better and things like that. So it doesn't matter, but whatever calculator you decide to use, understand it, okay? Sound good? Okay. Now the second point I would make is, let me grab that, okay. The second point I would make is know this, what I'm handing out right now. And what am I handing out right now? I'm handing out snippets from the reference manual, specifically this. I'm going to borrow this. So I got a student here who brought the NCEES reference manual that you will be allowed to use during your test. Now, when I took the test, I had a hard copy like this. You were allowed to bring a calculator and this. That was really basically it. You couldn't even bring your own pencil, because there were folks who would bring in pencils with camera scanners. They would scan questions and then go sell them to testing prep companies and whatnot. That stuff happens. This is a document that you're really going to want to understand. Now, when you take the test, it's going to be computer-based, and you're going to have a digital PDF of this. I would make sure that you understand it, okay? Now, you have a hard copy. My advice to you would be use this for every class you're taking this semester and from here on out. Understand the notation. Understand where things are. Where are the definite integrals or indefinite integrals in the book? Where are the z-scores for normal distributions and all that? Where's your periodic table? Where's the Moody diagram? All of that stuff. Make sure that you understand it because it's very critical. Let me go ahead and hand out some of these. I way overprinted because I thought I'd have like just about everybody here. There you go. That did not happen. What's that? Gang's all here. I apologize if my voice goes in and out. I'm getting over a cold. I went to Nebraska recently, and they returned the hospitality by bestowing upon me a cold. So, gotta love it. Okay. What I'm looking at right now is the NCEES reference manual. And I've got the section associated with math. Now, I'm going to cover just about every single pure math-based problem you're going to get on the exam in some form or another, other than one section, and that's prob and statistics, because you're going to see when it's all said and done, we're going to cover quite a bit, and I had to cut it somewhere, and that's what I decided to cut. Now, specifically in the math section, a lot of this stuff I think you're going to find is fairly pedigree. You know, you've got stuff on the straight line, quadratic equation, distance formula, properties of logarithms, complex properties, you know, with a plus bi. One thing you should note, you all are probably used to the imaginary number being I. In the reference manual, the imaginary number is referred to as J, and the reason why is really because of the electrical folks. The electrical folks like to use I for current, so that way they don't get confused. Let's see. Got trig properties, law of sines, law of cosines. We were mentioning that a little bit right before class started. Trig identities, which is something you're probably going to want to go through. This is the type of stuff that we're going to be talking about tonight. Properties of areas, particularly parabolas, ellipses, circular segments, spheres, regular polygons, all the 3D stuff, paraboloid of revolutions and all that. Conic sections, you all remember most of your fundamental graphs can be represented by two inverted cones and a plane cutting through them. So you can get an ellipse, you can get a hyperbola, you can get a parabola, you can get a line, all that. So parabolas, ellipses, hyperbolas, circles, differential calculus, the derivative, integral calculus, the integral, all your derivative identities and integral identities that you will need on the exam, centroids, moments of inertia, series, power series, Taylor series, Diffie-Q, which if you actually pay attention to the Diffie-Q section in the manual, a lot of the Diffie-Qs that you could get on the exam are solved for you right there. So don't let the Diffie-Q section scare you. That happens a lot. When they see a Diffie-Q, a lot of students just go C and move on. If you actually look at it, it could be plug and chug. So just think about that. Fourier series, this is where we're starting to get into the stuff that as civil engineers and mechanical engineers, we're probably teetering towards. This really isn't going to be on the exam. If you were electricals, I might say otherwise. Fourier transforms, all that. Laplace transforms, matrices, matrix math, that will be on there. Determinants, identities. I know you all are big fans of that whole IJK stuff and all that. Gradient, divergence, curl, Calc 3 stuff. Numerical methods, probably not on the general math section. And that's basically it. That's the math references that are provided to you for the exam. Does anybody have any questions? All right. Now, unlike my structural analysis and structural design sections where I have a few problems that are very long and very comprehensive. That's not really how this review is going to go. We're going to have a number of short problems, but they each cover a specific set of mathematics. So I've got the problem, you all have the handouts, and we're just going to start hitting it up. And it starts basic, and it gets more advanced as we go. Okay, so problem 1. Let's just sort of take it up. All right, so problem 1. What is the length of a line segment with a slope of 4/3 measured from the y-axis to a point 6, 4? Okay, so I know this might seem pretty convoluted, but it's really not, because you're provided some information that's pretty straightforward. To start off, you're provided with a slope of 4/3, right, and a point, right? Y'all remember point slope formula? Remember this? So let's just sort of get into it. So let's start off with point slope formula. So point slope formula. Okay, so we have a slope of 4/3, and we have a point of 6, 4, right? So what do we have? Y minus y1 equals m times x minus x1, right? So that is y minus 4 equals 4/3, bless you, times x minus 6. So y minus 4 equals 4/3 x minus, and what's 4/3 times 6? What's that? 8. There we go. So add that over, and I get y equals 4/3 x, get ahead of myself, minus 4. So far, so good? So this is the equation of that line. Everybody okay with that? Now, let's take a look at the graph of that line. What would the graph of that line look like? Well, it would look something about like this. Here's the x-axis. Here's the y-axis. We would start off at, what is that, a y-intercept, maybe something about right here, right, where that is 0 minus 4, and the line would in turn look something about like that, right, where the slope of that line is, oh, I did that backwards. I can't use the undo there. Let me just erase. Rise over run. Whoops. So far, so good? Now, everybody okay with this? Okay. If you're okay with this, then let's read the question again. What is the length of a line segment with a slope of 4/3 measured from the y-axis to this point? Okay? So when we're talking about the length of a line segment, I mean, how do you calculate the length of a line? It's really just the Pythagorean theorem. Because if I have point A and point B, it's the distance formula. It's the square root of the sum of x change in x squared plus change in y squared. So I need 2 points. Well, I propose to you that my 2 points are, I'll do it in green or something. My 2 points are 6, 4 and 0, minus 4, right? That really what I'm after is the distance from this point to, maybe it's a point somewhere over here. Maybe that's 6, 4. Does that make sense? Pretty straightforward. And how do you calculate the distance? You'd say, I might move down here a little bit. The distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. Not too bad, right? So, Remember, you can do this in any order you would like. Just be consistent. So if I say x2 minus x1, I could just look at it vertically, and I could say, how about 6 minus 0, and then 4 minus negative 4, right? Just keep track of your signs. So we've got 6 minus 0 squared plus 4 minus 4 squared. So that's the square root of 6 squared plus, what is that, 8 squared? So that is the square root of 36 plus 64, which is the square root of 100. All right, what do we think? So far, so good? Any questions? Getting us back into the swing of things, right? All right. Now, let's change it up a little bit. Problem 2. All right, so let's go through what's going on. So what is the general form of the equation for a line whose x-intercept is 4 and y-intercept is 6? Okay? Now, right off the bat, if you don't remember what general form is, it's really not that big of a deal, because just look at the question. You could just rewrite the equation of this line in this form, and there you go. But if that doesn't help, that's where the manual comes into play. Go into your conic sections location in the manual, and all that stuff is there. But all in all, this is nothing more than finding the equation of a line. Now, to find the equation of a line, you either need one of two sets of information. You need a point and a slope, or you need 2 points. Now, instead of being given a point and a slope, we were given 2 points. What were the 2 points that we were given? There we go. So 4, 0, and 0 minus 6. Sound good? All right. So what can we do with those 2 points? We can determine what? The slope. So I propose that the slope is the change in y over the change in x. And you just got to be consistent. So if we say y2 minus y1, we'll say negative 6 minus 0. And then x2 minus x1, 0 minus 4. Sound good? So on the top, we get negative 6. On the bottom, negative 4. That's positive, right? Now, B is our y-intercept, which is what? Minus 6. So here, I'll do this lower. So y equals 3/2 x minus 6. Now, right off the bat, I don't have any fractions, so why don't I just multiply everything by 2? So 2y equals 3x minus what? Make sure y'all are paying attention. All right, and then getting everything all over to one side, all I need to do is just subtract the 2y. 0 equals 3x minus 2y minus 12. So what's the answer? There you go. What do we think? Any questions? That's That's a good question. Let me see that. Actually, no.
Formula's right underneath that.
And there's C even have given 2 points.
So it does have that.
Yeah, they put it right beside it for you.
That's a good point, and that's sort of the point that we need to make here. Are you coming in? Are you here for the FE session? Oh, never mind. Thermos. I don't know. I figure it was.
What kind of time constraints are we looking at?
That's a good question. Let me put it like this. Okay, so the question was, what's the idea on time constraints? It's more about the format of the exam. Let me hit escape here. Okay, so you're a mechanical engineer, so I'll do the mechanical engineering first. If you go to the very end of the manual, you'll see something called exam specifications. And if I go to mechanical on page 274,
We only have 69 questions.
well, actually, let me see something. What I had was for civil. The civils have 7 to 11. So,
I've got a sheet right here.
well, you're probably looking at this, right?
Yep.
Okay, so let's put it like this. So the exam contains 110 multiple choice questions, and you have 6 hours. So if I say 6 hours, 60 minutes, that's 360 minutes. 110 questions, that's about 3 minutes a question. But it's not as simple as that, because some of the questions that, for example, are in the math section are guaranteed to be quicker questions than, let's say, HVAC or Thermo 2 or heat transfer. Because you're a mechanical engineer. You're being tested on heat transfer and HVAC and machine element design. That's what they care about. And those are your more comprehensive questions for the mechanicals. For the civils, you're going to have math questions, but really they care about your open channel flow problems and your reinforced concrete beam problems and your shallow foundation problems and stuff like that.
This math is just to make sure we aren't idiots.
That I wouldn't put it like that, but
Would there be any conceptual problems with that?
possibly, and I think I actually have a couple. If I remember, the last iteration of my problems did have some conceptual questions. Let me see. I think I might have some near the end. Oh well, we'll figure it out later. I don't want to sit here and flip through this and waste time. All right, does anybody have any questions about this? Okay, now, this one's probably going to flex your use of the manual a little bit more because it's been so long since you've done stuff like this. Okay, simplify and evaluate the following expression. So how much experience do you all have with logarithms?
You can put it all in one equation, right? We say log base 3 of 3 halves plus 12 minus 2, right?
Times 12.
There we go. Now you're remembering it. There you go. Okay, let's sort of write all this out. Okay, let's start off with, let's just write it out. Okay, so log base 3, or the base 3 log of 3 halves plus the base 3 log of 12 minus the base 3 log of 2. Now, I'm going to start off by keeping this pretty basic and look at, okay, that is the worst bracket I've ever drawn. Look at that. Okay. So here I've got a term where I'm taking 2 logarithms that are the same base, that are of the same base, and I'm subtracting them. And I propose that the properties of logarithms tells me that if I have the log of A minus the log of B, it is the log of A over B, A divided by B. So this is, or this term becomes, we have still over here log of 3 halves plus the log of 6, because 12 over 2 is 6. Likewise, if I have the log of A plus the log of B, it is the log of A times B. So I propose then that we have the base 3 log of 3/2 times 6, which is the base 3 log of 9. Make sense? Now, there are ways that you can evaluate this with your calculator. Some calculators will be able to handle a logarithm of any base, some won't. But what I would prefer to do, since this is a mathematics review, is I would like to recall or remember just what the hell is a logarithm. A logarithm is an exponent or an exponential just written another way. I propose that if the base 3 logarithm of 9 equals x, then x is whatever that magic number needs to be such that 3 raised to the x is 9. That, in other words, these two equations are saying the same thing. And I don't think you need a calculator to tell me what's the answer to that question. 2. Not too bad, right? Yes, sir.
I think, I'm not pretty much which way it goes, but it's like log base 10 of 3 over log base 10 of 9 is the same as that.
Yeah, it's the change of base formula. And I believe that the change of base formula is, in fact, in here. Yeah, it's right here. The
log base B of x equals log base A of x.
yeah, so if you've got, so if you want, you can say the log base 3 of 9 is, let's say, the natural log of 9 over the natural log of 3. Or, you know, base 10 log or whatever. Base 10 being your common log, base E being your natural log. Yeah. All right. Sound good? Okay. Any questions? Going through these a lot quicker than we did the shear and moment ones, right? Oh, goodness. All right. Now, this one's going to test out the trig a little bit. Oh, yeah. Getting down to it. So, for some angle, the cosecant of that angle is -8/5. What is the cosine of 2 times that angle? Right? Just a bunch of stuff there. All right. Here's Dr. Michelson's tips and tricks when it comes to problems involving trig. My advice when dealing with trig is, when possible, split it up into sines and cosines. Get everything back to sines and cosines. It might be more algebra and it might be more stuff going on, but everything gets simpler, I believe, when you break it down into sines and cosines. Let's start off with what's been given. Okay, we've been given the cosecant of theta is -8/5. Now, if we've been given the cosecant of theta, that is a term that we know. Is there a way that we can take that and turn it into sines and cosines? Okay, how so? One over sine. In other words, if I have the cosecant of theta is -8/5, I propose to you that the sine of theta is -5/8. Sound good? Now, I know this. What I'm trying to find is that. So how do I do that? Well, is there an identity we can use?
Inverse sine of that.
Well, we could.
2 times that, cosine 2 times that.
That's a possibility. We could do an arc sine or an inverse sine to get an angle. And then we could say, all right, now that we got that angle, cosine of 2 times that angle. I'm lazy, and I would like to explore the use of this manual a little bit. Is there an identity that I could use? What about this one? On page 24, about middle of the way down, I see that the cosine of 2 alpha is 1 minus 2 sine squared of alpha. Everybody see that? So I propose then that the cosine of 2 theta is 1 minus 2 times the sine squared of theta, which is 1 minus 2 times negative 5/8 squared, which is 1 minus 2 times 25 over 64, which is 1 minus 25 over 32. Which is 7/32. What do you think? Isn't too bad, right?
In the beginning, could you say 1 over arc sine of 8 over minus 8 over 5? Instead of like flipping the fraction and like 5 over 8, could you say 1 over sine of minus 8 over 5?
Okay, what?
Because the original thing.
Well, no. If you wanted to find phi, or sorry, theta would be the arc sine or the inverse sine of negative 5/8. Okay, so you couldn't flip that because let me say this: the inverse sine of x does not equal 1 over the sine. It's not the same story.
Yeah, what I was saying is 1 over cosecant is 1 over sine is cosecant, right?
Yeah, and that's where we went from here to here.
And so I was saying if I just kept it like that and said 1 over sine of minus 8 over 5.
I don't think that would work.
You don't think that works?
I'm the way I'm following it, no, unless I'm missing something. I don't think that would work. Unless I'm missing something. Hold on, let me make sure. What's that?
You split, like, it's 1 over sine, so you split the, like,
But are you trying to take an arc cosecant?
No, I'm taking arc sine. Just 1 over arc sine of minus 8 over 5. Is that the same as
1 over arc sine of minus 8 over 5. Yeah, because you're predicating that on this. And that's not the case. In a backwards way, you're predicating it on that, the way I'm understanding your proposition. Did that work? Did you try that? Okay. I didn't think it would because I think you're in a roundabout way trying to do this.
but you can't take sine inverse of negative 5 over 8.
Yeah, no, that's fine. That's fine to get a theta and then take, yeah, no, that's fine. And that is a completely plausible way of doing it. My whole point was to try and get you all to go to page 24 and go through the, no, I'm trying to get you to use the reference manual. Ooh.
I feel like it's just faster doing it with just the inverse of that there.
What's that?
I think it's faster doing sine inverse of negative 5 over 8.
I am glad that you think that because now we've got this one. Oh. Now I'm making you use them. All right, in all seriousness, does anybody have any questions here? Did your question get answered?
Yeah.
Okay.
I just kind of solved it. It's just you do that, right?
What?
Like, where we got sine of theta equals negative 5/8. I just put passed down and solved for theta. It's like negative 8 plus 6/8.
Yeah, point degrees, and then yeah, that's the same thing that we're talking about. Yeah. Again, I'm just trying to get you to use the.
I'm pretty sure I could
No, absolutely. There's nothing wrong with that at all. Nothing wrong with that at all. It just is not using the identities. Whereas you've got to use the identities for something like this. Shucks. Now, I would argue of all of the sines and cosines problem, this is one that I think you need to get into sines and cosines. Now, what I mean by that is I want to take each of these trig expressions and see if I can get it into terms of sines and cosines, and can I simplify it a little bit. So let's start off with each of these side by side. So the cosecant, I can write the cosecant as, so I have 1 over the sine of x times the cosine cubed of x, but we'll put that over 1. And then times the tangent. What can I do with the tangent? There we go. Sound good? Now, what can I do right here? And I can also cancel a cosine, right? So I get this. But that's not a choice now, is it? Now, does anybody know what the answer is? And what's the answer? C. Now, how do you know that? Well, we do know that the sine squared plus the cosine squared is 1.
I was like looking over here for cosine squared.
I would argue.
It's been a long week.
No, that's fine. This right. Wait, it's Monday. Says it's been a long week. It's Monday.
Exactly. Long 8 hours.
Yeah. This identity that the sine squared plus the cosine squared equals 1, it's one of the more critical ones I think is worth memorizing. The big kahuna.
We use it so much.
Yeah, it's a very fundamental identity in the world of trig. It basically is the equation of the unit circle. That's basically what's going on. Okay. Anybody have any questions? Turn the air off. Could you turn the air off?
That was a demand.
You must turn the other one.
Apparently the answer is no, because I'm hitting the on-off button and the light's still on. Okay. Next one. What is the value of x less than 360 degrees that will satisfy the following equation? Ooh, this one's tricky. Yes, sir.
Could you use the Casio solve function?
You could. That's very possible. You could just plug in the equation and hit solve. Or we could look at this. Imagine that the sine is some other variable. Let's say u is the sine of x. Then would that be u squared plus 4u plus 3? Kind of looks a little bit like a polynomial, right? So let's try that out. Give me a moment. What's that? Something like, yeah, or let u or let a, whatever. Yeah, let's let u. So let's let u equal the sine of x. So it's kind of u substitution without the integral. So right? What's that?
There's so many ways to do these math problems.
Yeah, just comes with practice and the quickest way you can. All right, so what can we do with this? What's that? Well, we could do the quadratic, or we could factor it by saying it's u plus 1, u plus 3. Sound good? Now, so would this yield u is minus 1 and u is minus 3? Sound good? Now, u was not the original variable. It was sine of x. I want to look at this one over here. Sine of x is -3. What's going on with that? When does the sine of x equal -3? Never. It never does. Because, let's go back to the graph, right? Graph looks something about like this. Right? This is pi, 2 pi. So you've already figured it out, right? That it's 270. Because this one, well, that's fine. And honestly, you're making a very good point that... Because it's flipped off, because it's repetitive. There's an infinite number of solutions technically, but where it's asking for less than 360 within the choices, there's really only one. But -90 isn't a choice. So, first off, this one makes no sense. So I'll say invalid. And I'll say for this one, only at x equals 3 pi over 2 or 270 degrees. But if you are that strong with your calculator that you can just knock it out, that's fine. But this is one of those questions where it's really dangerous, or it's really easy to just say, oh, it's B. It's B. No. That's a good question. Remember the magnitude of the sine of x. It only goes from +1 to -1. The amplitude of that wave only goes from plus and -1. There is no quantity where the sine of x equals -3. That's a good point to make.
It would be like -√pi, and that would be like...
Well, that you're talking about the x would be...
It'd have to be 3 sine of x.
Yeah. You'd have to adjust the sign, adjust the magnitude by 3. The amplitude of that wave. Remember, if you put a 3 inside the sine function, it changes the frequency. So.
Like it would be...
This is good stuff, right? Good stuff. Any questions? Think we've already done 6 problems. It took me 2.5 hours to do 6 problems the other night, right? We're already on problem 7. What's that?
Group FE?
Group FE. Yeah, about that. You can ask NCES. We'll see what they say. If the rectangular coordinates of a point are -3, -5/2 or 5.2, what are its polar coordinates? So, let's graph that out. So we're talking about a point. What's that? Yeah. So -3, -5.2, we're talking about a point that's about right here, right? Okay. So, what's up? Oh, you're going with this one?
We're saying like if the first number can't be negative, right? Since the magnitude is going to the line.
There you go. See, I was going to make these points later. Goodness. You're stealing my thunder.
We're just trying to figure it out. That's as far as we got.
Yeah. All right. Goodness. Okay. Excuse me. So first off, okay, we know that this is 3 and this is 5.2. So tell me, polar coordinates, we need the radius. We need r. So how are we going to find that?
You don't need to.
That's a great point. You don't need to, because we already know what the answer is going to be, right? It's going to be 6. It's got to be 6. There's no other possibility. But for the heck of it, how do you find it? There we go. And what do you get? My goodness.
Did an automatic pass if we find a mistake with the test?
No, but I'll say this. When they grade the test, there's a lot of statistics that are done assessing the scores. Like if 95% of the country missed question 12, maybe there's something wrong with question 12. You know what I mean? So. Now.
Let's all jump in and just miss every single one of them. We'll all pass.
I don't think they throw them out.
Yeah, I don't think that would happen.
For like a whole, yeah, for like a whole year, you have to people about to.
It's worth a shot.
All right. Now, let's look at a couple things. All right. The next thing I want to do is I want to compute the angle. Now, specifically, I want to look at this angle right here. All right. So, I seem to remember my good friend Sakatoa, right? So, I propose that the tangent of that angle is that over that. Well, you never saw Sakatoa?
No, we did some on hippie caught another hippie tripping on acid.
That's what my high school taught.
Some old hippie caught another hippie tripping on acid. I'll be damned. I've never heard that before.
We're on the Sakatoa. I'm the Sakatoa kind of guy.
This was my high school.
Damn. That's awesome.
That's the only reason I remember it, though.
I've never heard that before. That is amazing. All right. Let's do this, okay? So, how do we count? So, someone tell me what theta is. Theta is the arctangent of 5.2 over 3. And what does that come out to be in degrees?
Yeah, 60.01.
So, we'll say 60 degrees. Okay. Now, how are angles measured in polar coordinates? Well, in polar coordinates, we start here, right? Along the x-axis. And then this is positive angles. This is negative angles. Now, what would it be if it was a positive angle? It would be 90, 180, 240. It's not 240 because that's not a choice. What about negative? Negative 90 and then negative what? 30. So 6, negative 120. Some old hippie caught another hippie tripping on acid. Wow. That's beautiful. That's just beautiful.
It worked.
Any questions about the polar coordinates? Everybody good? All right. Okay. Determine the x and y coordinates of the center of the circle defined by the following equation. Okay. Now, if you don't remember the standard form of a circle, that's where this comes into play. Now, there are properties of a sphere and this, that, and the other. But if you go to page 27, the standard form of a circle is this. You all probably remember that from pre-calculus, if I'm guessing. Somewhere between algebra, trig, and calc 1, somewhere in there. Okay? Now, the radius of this circle is r. The center of this circle is h comma k. So what we need to find is h comma k, the center of the circle. Now, here's the equation. All right. The first thing I'm going to do is I'm going to be systematic about this, and I think you're going to see here in a second that I might have wasted a little bit of time, but I'm going to be systematic. I'm going to take that number, the 25, and I'm going to put it on the other end. And I'm going to say x squared minus 8x plus, and I'm also going to do something else. I'm going to put some space out here. Y squared minus 10y equals 25. Now, I added some space there for a very specific reason. We're completing the square.
Oh, God, no.
What's that? You hate that? It's simple. All right, here's completing the square. I want to be able to factor these x terms into x minus h squared. Okay? In order to do that, I need to take this coefficient of the 8, half it. So what's half of 8? 4, and then square it. So 4 squared is 16, which, oh, you all weren't paying attention. That's a negative 25. All right. So I propose to add 16. But if I add 16 over here, I got to add 16 over here. And we'll group that. Now, what am I going to do for the y's? Well, same thing. What's half of 10? Squared is 25. So this is where I was saying if you pay attention, I might be a little redundant because there was already a plus 25 there. I could have just used it. But I wanted to be systematic about it because I think that's what's easier to remember is the process, not, you know, oh, yeah, there's a 25 already there. So on the left side of this equation, how do the x's factor? If I have x squared minus 8x plus 16, how's that going to factor? There we go. And what about the y's? How's that going to factor? And over here on the right, it doesn't really matter. We're going to get 16, but we don't really care because all we needed was the center of that circle, which is 4, 5. Well, the standard form is x minus h. So h is 4. If it was x plus 4 squared, then the center would be negative 4, 5. It's a good question. Okay. Everybody good? Any questions? Uh-oh. Uh-oh. What is the slope of the following curve when it crosses the positive part of the y-axis? The slope of the curve. It happened. Calculus. Some old hippie caught another hippie tripping on this, and I'm still having a hard time getting past that one. Okay. What is the slope of the following curve when it crosses the positive part of the y-axis? So right off the bat, we need, what's that?
X-axis.
Positive part of the x-axis, yes. Right off the bat, what are we going to need? The derivative. And what is the derivative of that? 2x. So whenever we figure out what the value of x is, we just plug it in there, and then we're good, right? So what's the value of x? Well, we need to figure out where it crosses the positive part of the y-axis. Let's ignore that positive part for a second. When you cross the y-axis, or I'm getting it backwards again. When you cross the x-axis, what's going on there? Y equals 0. So I'm going to take this curve, I'm going to set y equal to 0, and I'm going to solve for x. Let's just see what we get. That Sakatoa thing's still tripping me up. So how do I solve this?
I really need to take like algebra. Yeah.
What?
Yeah. When it comes to algebra.
Oh, okay. All right. You haven't been tripping on acid, have you? Okay. All right. So 3 plus or minus the square root of 9 plus 40 over 20, right? So equals 3 plus or minus 7 over 20. So I get x equals, was it 10 over 20 or minus 4 over 20, or x equals 1/2 comma minus 1/5. Which one do I use? The positive part of the x-axis. So I go back up here and I say dy over dx at x equals 1/2 is we had to bring that derivative in there somewhere, didn't we? Any questions?
If you use the Casio solve function to solve for x, why doesn't it give you a negative value before a positive value?
It should.
Yeah, I pushed equals like 4 times.
Did you hit down?
No. I'm gonna do it again.
Hold on, let's see. I'll check. So I'm going to mode 5, and then, which one is it? 3. A is 10, B is minus 3, C is minus 1. Hit enter, it solves, and then I hit down, up and down.
See, I didn't go into the.
If you don't go into the workflow, it'll show you one or the other.
I just typed it all in. It's typed this solve, but it gave me the positive one. So
I got the negative one.
oh really?
If you go to mode and then go to equation, go there. Sound good? Keep in mind, it will also numerically differentiate. So you could just say dy dx at x equals 0.5 of that, and it'll just tell you. So you just got to be careful. Everybody good? What's that? That can happen. That can happen. Now, This one is a little bit more of a purist calculus problem. What is the maximum value of the following function on the interval x is less than 0? So, what do we got to do? So, we got 2x cubed, so that's set that equal to 0. Now, before you all just get calculator happy, maybe we can be a little, strategic about this. There we go. Maybe I can say maybe I can do that. What bad practice?
Just, I would remove the 6.
Well, okay, if you want, I can, all right, let me do this.
Well, maybe it's only when it typed it.
Do you need to worry about the positive form? Like where it says x equals 1 and x equals -5?
Yeah, no, I'm getting there.
Okay.
Because we're only going to use this one.
Yeah,
Because
the value's less than 0.
that's the interval.
Okay.
But what you're talking about, if I just divided everything by 6, what's 0 divided by 6? Now, what you're talking about is factoring out an x. That's a good question. All right, so take this value of -5, excuse me, plug it back in. First off, let's see what we get. What do we get when we do the plug and chug there? Well, let's take this one step at a time. So this is 2 times, what's -5 cubed? -125 plus 12 times 25. And then I've got negatives here, so I can just say plus 30 times 5 plus 10. So this is -250 plus 12 times 25, that's what, 300? Plus 150 plus 10, that's what? So, I'll go ahead and tell you that that is the answer. However, all we did was take the derivative, set it equal to 0, solve for x, and then plug it in. That does not necessarily tell us that that value is a maximum. It tells us that that is an extrema. How do we, it is an extreme value. How do we determine whether or not it's a minimum or a maximum? Remember the second derivative test? Check, well, you could check the boundaries and we can go through all. Well, first off, the boundary is really just x is less than 0, so it's just 0. So if I plug in 0, I'm going to get 10. So the numbers tell me that this is a maximum. But another way I can do this is I can check the concavity. And I check the concavity by, let me do this. I check the concavity by determining the second derivative. Now the second derivative is the derivative of this, which is what? 12x plus 24. And if I plug in minus 5, I get was that minus 36? So what that means is that this is concaved downward. In other words, excuse me, the curve looks something like this. And this is at x equals minus 5. So it is a maximum.
Negative, you get a brownie.
Something, yeah. Something like that. The second derivative test. Y'all remember that? All right. Sound good? Any questions? We're halfway done. All right. What is the value of the following limit? Ooh. That's all calculus is. What do you think a derivative is? It's just a special limit. What is an integral? It's just another special limit. I did not have Q6.
Every exam you would what is calculus the study of? Or in some form, calculus in the answer would be calculus is the study of every single exam.
Okay.
Yeah, I'm not.
You don't know how to do this.
Oh, do you love L'Hopital?
This is a L'Hopital. This is an L hospital problem. This is L'Hopital's rule. Why is it L'Hopital's rule? What happens if I just plug in 0? No. You get 0. This is an indeterminate form, 0 over 0. So L'Hopital's rule tells me that I take the derivative of the top and then the derivative of the bottom. So I propose then that this equals the limit as x approaches 0 of the derivative of the sine of 5x over the derivative of x. Now, what's the derivative of the top? Cosine 5x. 5 cosine 5x. Remember, chain rule. You take the derivative of the outside times the derivative of the inside. So we have 5 cosine 5x. Then the derivative of the bottom is, so we can now plug it in. That's the nice thing about a limit, is that if you can plug it in and not get a division by 0, just plug it in. So 5 what's the cosine of 0? Okay, I'm moving this thing if I can. That thing is bugging me. Like some folks tripping on acid or something. Hippies tripping on acid. Yeah. You know that there's some math professor somewhere that just has a painting in their office of, some hippie sitting there by a tree stump going like this, and another hippie like.
You should commission that work and then
Oh, goodness. What is the partial derivative with respect to x of the following function? Remember, how does this work when you take a partial derivative? X is the variable. Everything else is a constant. So we are taking the derivative of f with respect to x. So, one term at a time. The derivative of x squared is plus the derivative of x is, so it's just y to the fourth, right? Okay, plus the derivative of the sine of x is, all right, the derivative of cosine squared.
Isn't it some crazy nonsense? That's the one I memorized right before you.
This is a chain rule because it is the derivative of a pile of junk squared. So I propose it's 2 times that pile of junk, then multiplied by the derivative of that pile of junk. That's the technical term for the chain rule, right? Remember the derivative of the outside function and then the derivative of the inside. The outside function is the squaring, taking this function and squaring it. So 2 times that function, all right? Make sense? So we took care of this. What's the derivative of sine cubed of y? With respect to x. What's the derivative of 4? 0. Remember, what's the derivative of 7? It's a constant. In terms of x it is. Now, none of those terms are specifically there, but there's a lot of commonalities. For instance, if I look here and here, are there any common terms? So maybe I'll say 2x plus y cubed. And are there any common terms, I don't know, let's say here and here? Well, what's the common for both of them? Cosine of x. And if I factor out the cosine, what am I left with this first term? 1 minus what? It's all being multiplied.
Oh, okay. I see the parentheses now. I'm just confused.
No, it's fine. Think about it. We've actually gotten through a lot of material tonight. We've done a lot of algebra, trig, pre-calculus, calculus, calc 1, calc 3. We're getting there. Any questions? What is the result of the following indefinite integral? Without doing any calculations, I want somebody to tell me what the answer is. Okay, you got D. What are you saying? Now, why are you saying A? Because it has a natural log. We're taking the integral of 1 over x. That's a natural log. But just to do our diligence, we have the integral of 15 times x to the 4th, so that's x to the 5th over 5, 3x to the 5th, minus 8, x to the 4th over 4, that's that, natural log, 7x, plus the arbitrary constant of integration. Simple, right?
Sure.
Oh, that was a simple one. All right. Since I know it's your favorite of the three, we'll be calc 2. All right. What is the result of the following indefinite integral? Oh. Circle C and move on. It'd be funny if that actually was the answer. What?
Oh, hell no. You gotta multiply that shit.
I type UP.
Well, something. Well, no, we're not going to separate it into UdV equals UV minus VdU. We're not doing that. We're not doing integration by parts. What I am going to do is do some substitution. Okay? Now, here's what I'm going to do. I propose let's let U equal the cosine of x. Now, why am I doing that? Okay?
It just comes back to you. It's just how you get the ball rolling. Yeah.
Because I've got sine of x dx. Does that make sense? So I propose that this component right here, that is u squared. This, no, negative du. Now, the integral of this is minus that or he said integral of u dv is uv minus the integral of v du. You don't, yeah, you don't need to go that route.
You could use that, couldn't you?
Technically, yeah. You can do integration by parts on trig integrals. Sometimes it's not very advantageous because what happens with trig functions is that they're cyclic. See, it's not like a polynomial. Like if I have x squared, I take the derivative, I get 2x. I take the derivative again, I get 2. The derivative of that is 0, and then it stops. Trig functions don't do that. If I take the derivative of the sine, I get cosine. Take the derivative of that, negative sine. Then negative cosine, positive sine, I'm back to where I started. So sometimes it's not advantageous to do that because you keep repeating yourself. You can still use it, but you got to be careful. Okay, that's a little extreme. Okay, what is the total area of the region bounded by the x-axis and the curve y equals sine of x on the interval between x equals negative pi over 2 and x equals 2 pi? Exactly. Draw a picture. I have to do better than that. All right, so what do we got? Something about like that, right? So this is pi over 2. This is 2 pi, right? I propose that if we want to determine the area bounded by the curve and the y-axis, in other words, this and this. Okay, first off, what is this point right here? Okay, I propose that if we're going to do this, we need to do a few safeguards. First off, split it up. And because I have a negative region there, and I want to calculate just this area, absolute values. Make sense? Now, what's the integral of the sine? Negative cosine. Now, if it'll make your life a little easier, you could say, all right, maybe if you said x and then, you know, negative cosine, what does it look? Something like this, right, if you wanted to do that.
Do you have to break it up over those 2 points, or can you just do it all at once?
No, if you do it all at once, you're going to have some cancellation here and here, because you're going to get the same value here, but they're going to be opposite sides, and it's going to cancel, and you're only going to be getting that. Where it said total area, I'm just going to do it separately. Make sense? All right, so we have that negative term, and then we can just say cosine pi minus cosine pi over 2 plus negative cosine 2 pi. Here, let me just do this. Minus cosine pi. And since I factored that negative out, maybe what I ought to do is I ought to redraw this graph here. So that's pi over 2. That's pi. Pi over 2. It's 2 pi. Sound good? Everybody okay with what I did there? Just graphing the cosine function. The reason why is because I wanted to do this really quickly. The cosine of pi, that's minus 1. Minus the cosine of pi over 2, that's 0. How am I doing that quickly? I'm looking at the curve. Plus, excuse me, I have minus cosine of 2 pi, that's 1, minus cosine of pi, that's minus 1. So I know there's a lot of negatives floating around there, so simplify that up a little bit. So inside that bracket, I have negative 1, so that's the absolute value of 1, plus over here, inside that bracket, I have 2, so that's the absolute value of negative 2. So that comes out to be 3. Another way of doing it would be this. If you recognize that that total area is just 3 of those, and that's 1, you could just figure out however you want to integrate it and then just multiply it by 3. Does that make sense? So, What's that?
So just remember that half the R or whatever is
The area is 1.
1. Does that mean that probably means that the whole thing is 2? The whole
Well,
area, the whole
this is 1. That whole thing's 2. So man, this is getting philosophical. All right. Please tell me that this is not a pass question. Now, there's 2 ways of doing this, and we're going to do it both ways because I feel that we should. Who has not had differential equations in here? Good, that's what I like to see. All right, so, oh, don't even. First thing we're going to do is solve it for real. Characteristic. So remember, second derivatives become r squared minus first derivatives become r plus the function's just the number, right? So r minus 4, r minus 4. And I get r is 4, but that's a double root. So when you have a double root, you have a constant times an exponential plus a constant times an exponential. But anytime you have another root, you have to add an x there. So if you wanted, you could factor it out and then just say C1 plus C2x. Right. Now, that is probably like, we're just going to guess C and move on, right? Now, I'm going to make it feel a little better. We're going to go to page 31. Now, let's actually just go through the cookbook on page 31. Okay? So I'm at the bottom of the left column. Second order, linear, homogeneous, differential equations with constant coefficients. I know that's a mouthful, but an equation with the form of y double prime plus ay prime plus by equals 0. That fits this, right? I'm on page 31. All right. Okay, can be solved by the method of undetermined coefficients. So we form our characteristic equation that you saw right there, but let's ignore all that, okay? I want to look at the top right column. What's A in this equation? Literally, just what does this say A is? Negative 8. What does B equal? Okay? Now, using these, what is A squared? There we go. What is 4B? What does it say? If A squared equals 4B, the solution is of the form y equals C1 plus C2 times e to the 4x. And how do you get R1? Literally, just solve the roots.
So, on the FE, do we expect the questions to follow the equation sheet? Or are we going to be flipping back and forth the whole time?
It depends on what section you're talking about. Math, I think you're going to follow this pretty easily, but you know, if you're doing, let's say, a steel design problem, you've got to flip back and forth to a number of eggs. It's just, it is what it is. Depends on, it's not as simple. I can't just say yes. It's not that simple. You know, if you're doing a fluids problem, you might have to flip back and forth between where Bernoulli's equation is and then where the Moody diagram is for friction. Not as simple as just yes, you know what I mean? All right. Sound good? But that's a good question, but it's not simple.
But they'll probably build from that.
What's that?
They'll probably build from like cap 1 all the way up to differential.
Yeah, I mean, if I remember correctly, they kind of went in order. They didn't, the first question wasn't a partial derivative, and then the second one, the equation of a line. If I remember correctly, it was in order, but that was years ago, so don't quote me on that.
That was a strongly worded letter.
Oh, goodness. Ooh, yeah. This is where it's at, right? Look at this one. Oh, yeah. IJK. First off, does it make sense that the answer is a number?
This is the dot product, right?
Ultimately, it's a dot product, right? We are crossing B and C. We then dot it with A, whatever that result is. Make sense? All right. Now, so this is bringing it back a little bit. So I don't know if this was ever named for you, but it is the rule of Saris, which says that if I want to do B crossed with C, I write a determinant. I do I, J, K. I then put B down, 1, 2, 3, 3, 4, 5. The rule of Saris states that I then go out here and I put another 2 columns, and I say all my products going this way minus all of my products going this way. So let's see. So the i's, I've got, what, 10i plus 9j plus 4k minus all of the products going this way. So, goodness, my nose itches. You could do it in order, but I'm just going to go with IJK with that order. So the I, 3 times 4 is 12. I got 5J and 6K. Does everybody see that? So this is minus 2i, just add up like terms, plus 4j minus 2k. Is everybody okay with that? Okay. Then to dot, it's literally just 6 times minus 2 plus 8 times 4 plus 10 times minus 2. So this is minus 12. That's 32. That's minus 20. It's 0. What do you think?
I got that.
You got that?
Yeah, I don't do the little stars with.
You just do it in your calculator?
No, I do it. I do it by just taking the original determinant and then taking like the I row and column out and then
Doing the determinant of the 2 by 2?
cross, yeah, and then
So you're doing sort of like the permutations approach or the adjoint approach almost, or something like that.
Yeah.
Did you take linear algebra?
no.
Okay.
I've just always done it the other way.
Oh.
People try to show me this and they never make any sense when they try and say it to me, so I've always just done it the way that I know works.
Then do it the way that works.
I think we call it cofactor
Cofactor expansion,
expansion.
yeah.
I think it's just as fast for me, I think.
Then it goes. You don't do that. You do cofactor? That's fine.
I don't remember that either. That's how I used to.
Oh. Oh. Everybody good? Okay. We have got 3 more questions. Now, what is the angle between the 2 given vectors? How do we do that? Well, if you don't remember, that's what this is for. So, I want you all, I've already found it, but I want to go to page 35, and I want to see if you all can tell me how to do this. Well, we can do that. Okay, say that a little louder. Can you use the dot product? Yes, you can. Now, if I had to choose, should I use the dot product or the cross product? What would you choose? Why? There we go. Now, but we are going to need a few things, okay? First off, you are correct. We need the dot product. So, what is the dot product? Can anybody just do that real quick? 36. Right? Just 4 times 12 plus 12 times negative 8 plus 6 times 6. Not too bad, right? Now, we're also going to need the magnitude of the A vector and the magnitude of the B vector. Now, how do you determine the magnitude of a vector?
You square them and sum them and then take the square root.
It's basically a Pythagorean theorem in 3D. You're exactly right. So, and what do we get for each of those? So, excuse me, goodness. So multiplying those two, I get 364. Sound good? Why does that matter? Because A dotted with B is a representation of the magnitude of A times the magnitude of B times the cosine of the angle between them. So the cosine of that angle is A dot B divided by those two magnitudes, which is 36 divided by 364. So theta is the inverse cosine of 36 over 364, which is what?
Oh, you gotta be in degrees.
You could take your answer, multiply it by 180, and divide by pi. You could do that. What's that? Oh, goodness. As long as you're not some old hippie.
Man, you would not pass that exam. You can test it.
That is a dare. Let me tell you, that is a dare right there. What's that? Oh, goodness. What is the determinant of the following matrix? Now, you should be able to. But you can use the rule of Saris to do this as well, or cofactor expansion. So it doesn't matter. Let me see something. So I want to see if anybody can just do it and tell me what you get. Because you've already done a cross product, so you can do this. Somebody got it.
Got the other one 6 times
54. Anybody get it? Oh, he got it. Anybody else got it? It is, in fact, 0. I mean, if you want, you can say 2, 5, 7, 3, 6, 8, then. You can do that. All right. Everybody good? I'd have to look it up. I know you can, but I have my last question, which I think it might be the hardest. It's a series.
Oh, hell no. Y'all have fun there.
Oh, come on.
Hey, 1 out of 20. This one.
All right. The second and sixth terms of a geometric progression are 3/10 and 240 over 1/60 respectively. What is the first term of this sequence? All right. Let's remember the difference between an arithmetic progression and a geometric progression. Now, what is an arithmetic progression? So, arithmetic, what's that?
Said I don't know always is my best thing.
Here's an arithmetic progression. We'll say r equals 2. 1, 3, 5, 7, 9, 11, etc. How did I get from one term to the next? You added 2. You added 2. Geometric, there you go. So 1, 2, 4, 8, 16, 32, so forth, so forth, so on. For some reason, when I write near the top of the screen, it gets jittery for some reason. The marker just sort of starts to, I don't know, it's weird. Okay, so here's what's going on. Okay. I'll erase this. Okay. So I propose that the second term I'm going to write here is 3/10, and the fourth term is 243 over 160. I propose that we need to fill the remainder of these boxes in. Now, I want to go to page 30 of the manual, page 30. So we're doing a geometric progression, okay? Now, the first term is A, okay? The common ratio is R. The number of terms is N. The last term, or the nth term, is L. So I propose to you in terms of notation, we've got L2, L3, L4, L5, L6, and then we've got L1, but that's just A. So far, so good? So, for instance, to calculate any term, L, it is A times R to the n minus 1. So, for example, L2 would be A times R to the 2 minus 1, which is AR. Sound good? L6 would be AR 6 minus 1, which is AR to the 5th. Sound good? All right. I don't know what the first term is, but let's look at these expressions. I know what L2 is. I know what L6 is. I don't know what the first term is, and I don't know what the rate is. But let's do this. Let's take L6 and divide by L2. Now, symbolically, what is that? We can ultimately get our common ratio as R to the 4th. Sound good? But the nice thing about this is that I now know what L6 and L2 are, because this also equals, let's do this. I also know that L6 over L2 equals what? 243 over 160 divided by 3 over 10. Don't I know that? So this is 243 over 160, flip and multiply. Right? So let's do some cancellation. Here, I get 16. Here, 81. So this is 81 over 16. So I propose that r to the fourth is 81 over 16. What's r then? It's 3/2. So check this out. Look what happens. Watch this. All right. I want you to take 3/10 in your calculator, multiply it by 3/2. Or you can do it in your head. Doesn't matter. No, well, yeah, I want to fill in the rest of this. What's 3/10 times 3/2? What's that times 3/2? And then, see it? Look what happens to the bottom. 10, 20, 40, 80, 160. 3, 9, 27, 81, 243. So what's left? Divide. 1/5. I did my best to try and be a little surgical with these problems. We covered a lot of stuff in a very short amount of time, and we haven't even been in here for less than 2 hours, really, and we haven't even been doing math the whole time because we did some stuff at the very beginning, going through the intro stuff. Does anybody have any questions? You feel a little better about the math stuff on the exam? This is pretty representative. And at times, a little trickier, so. Sound good? All righty. We will see you.
Thanks, sir. Thanks.
No problem at all.